And so basically this became a new approach. And in fact, we figured out the approach on the back of a napkin. I think you always hear those stories, but we figured it out that night in the French restaurant. And basically involved using secondary production data, gut analyses, assumed assimilation efficiencies, which we got from the literature, and this allowed us to estimate the amount each food type contributed to production. It also allowed us to estimate how much food each of these animals ate over the course of a year. Here you see the basic calculation. I'm not going to go over the details. Oops, I didn't mean to do that. This is for the caddisfly Arctopsyche aerata. I know a lot of you can't see the numbers, but basically we use these different assimilation efficiencies and estimated for Arctopsyche that the production attributed to each of these foods included the fact that 93% of their production was due to eating animals. These are filter feeders. And that didn't quite fly with a functional group kind of categorization. They're not supposed to be predators. So we took that information and that kind of approach and applied it to the others. Oh, how did I do that? Applied it to the other 5 species. Oh dear. Okay, there we go. The other 6 species. And it turned out that for 5 of the 6 total species, more than half their production was due to eating animals. So we figured, well, is this unique to this particular river up in the Appalachians? So that was a minor diversion. It told us some things that we didn't know before about caddisflies, and it turned out to be kind of an interesting approach. So the next thing we did, as I was saying a few minutes ago, was I got together with Judy Meyer, Bruce Wallace. We wrote a large proposal to an NSF on another river, the Ogeechee River, which is a couple river basins up the coast from the Satilla. There were a lot of publications from this study. Judy Meyer and her postdoc and students did a lot of them. I just want to focus on 3 publications, though, that Bruce and I put together that kind of follow up from some of the earlier work. One was quantification of wood habitat. This was an ecosystem study now, and we had to be able to convert the numbers from the snag surface area to per meter squared of river bed. And so we had to invent a procedure to do that. The second study looked much like the Tallulah River study. It was on the trophic basis of production of river and caddisflies, but in this case, it had to do with developing a food web. And you notice from the last slide that I showed you from the Arctopsyche, there was a column at the very end that was an estimate of the amount of food consumed. So we took advantage of that. We didn't think of that as a big deal back when we wrote that original 1980 paper, but let's be honest, at the time, back in the early 90s, frankly, I was getting tired. I like to read the food web literature, and I was getting really tired of all these connectivity diagrams. Dots connected with skinny little lines, and developing our theory of food webs based upon this kind of approach, and applying it to food webs that were never really intended for that purpose. So I was not especially happy with what was coming out in that literature. So I said, Bruce, we can quantify this. We can quantify connections. And so we did that, and we'll get to that in a minute. Okay, the habitat quantification of the wood, we borrowed an equation from the forestry literature. We converted biomass of wood for downed wood after the big trees had been removed, converted to surface area of wood. Here's Bruce and his technician Arnie using this line transect technique. We generated some good numbers. We then figured out a relationship between river height and wood surface area. And here you can see, if you look at the top line, that's for the Ogeechee River. Black Creek was a tributary. But what we found was that for most of the year, there was a high fraction of surface area compared to the benthic habitat. And so the snag surfaces were really a significant portion of habitats available to invertebrates in this river. Why is that not moving? Okay. Oh, okay. So from wood quantification, let's get back to the bugs. So it only took Bruce and I 17 years to realize that our trophic basis of production paper could generate flows and quantify food webs. We had always planned to do the trophic basis of production for these river and caddisflies to compare it to the Tallulah River, but what we didn't realize was we could do the food web as well. And so that paper came out in '97, and here's what the diagram looked like. And it turned out that production of caddisflies on these snags was much, much higher than in the Tallulah River, but the flows were also extremely high. You can see some of them up here, and it turned out some of these flows were from eating animals once again. In other words, for a couple of species of caddisflies up there, there are about 10 grams of animals being eaten by these filter feeders. That's a lot. And so you can see in the diagram over here some pretty heavy arrows going into H. rossi and Comatocyke. But we finally got around to doing a bit more of the rest of the food web. And so here you see all the predators. Here we have on the second row here with the Comatocyke and the Hydrocyke, we have them being the primary omnivores. Then we have a row of what's all stoneflies, and then we have a row of dragonflies, and up at the very top is Corydalus. And I didn't mean to do that again. But notice from this diagram that the heaviest flows of consumption of invertebrates are to the omnivores, to the net-spinning caddisflies. Now, that's all I'm going to say about food webs, except that last year I published a kind of a synthesis article on food webs. That was in Nature Education Knowledge. It's not in the Web of Science, so you just have to kind of search for it online. But if you're interested in these comparisons, you can go to that. You can see the connectivity web on the far left. Shaded in blue is the flow web I just talked about. And then you can do another kind of a top-down web I call an IP web, an ingestion divided by production web, for comparison. And obviously, they're very different. Now, just want to touch base on one paper that I think of as my service paper, or our service paper to NABS. And that was to develop an up-to-date version of length mass regressions, following up on Len Smock's classic study that was published in 1980. And Len was a part of this, but Alex Hearn and Bruce Wallace and Len and I had been doing production studies all these years, and it seemed like a waste that we didn't publish our length mass regression. So I got together with him and I said, let's do this. We can generate who knows how many equations. And while we're at it, why don't we just survey the literature on everything that's published? So that's how this paper came about. I can tell you that this paper is now my highest cited paper. And Len, it just surpassed your 1980 paper. And it's Alex's highest cited paper. It's not Bruce's highest cited paper, but it's been very popular. And so it's kind of ironic when I say there were no wow moments in this paper. It's very straightforward. It was simply intended to be used by NABS and anybody else that wanted to use it. So I think we were successful in that regard. So just briefly, here's some of the equations by insect order, by family, and by genus and species. So if you can't find an equation you can use there, do your own. Now, I want to briefly touch on some of my adventures in river conservation. It was mentioned in the description of what I've done. you can't see the lettering on the article on the left. It was published in JNABS, but it was entitled A Perspective on America's Vanishing Streams. It was based upon my presidential address in 1989. I'll tell you a little bit more about that in a minute. I have a very narrow arrow connecting that with the book that I did, which was mentioned by Joe, and the paperback version of it, but I'll get to those as well. Let me just say a few words about this Vanishing Streams paper. I had just become the NABS president in 1988, and a former president, Vince Resch, that most of you know, walked up to me and he said, "Art," he said, "you have to understand the tradition here in NABS. When you give the presidential address, you don't talk about anything you really know anything about." And I believed him. I'm thinking, what can I possibly talk about? I can't talk about secondary production or dragonflies. And so I have to tell you, a couple months ago, I was talking to Bruce Wallace on the phone, and I told him that story. You know what he said? "Vince was just kidding." I don't know if he was kidding or not, but anyway, it got me thinking about what can I talk about. And it occurred to me at the time, back in 1988, that NABS was doing essentially nothing about river conservation. I think most of us thought it was a little bit beneath us. It wasn't academic, it wasn't research, but I felt that we needed to do something about that. And in order to do something about that, I felt we needed some sort of examination of kind of the state of America's rivers. And there was no such thing. And at first I didn't have any idea how to go about doing this, but I managed to find some data in some government reports. And that was basically how my paper came about. And I'm not going to dwell on this, but I will say that the results from this were that it was clear that the vast majority of our major rivers are regulated with dams and levees. Now that doesn't come as a big surprise even back then, but I got some data that quantified that. It turned out that most large dam sites where one could put a dam were already taken. There weren't essentially any left. We were truly a damned nation, at least in the lower 48 states. From another, I can't even call it a report, it was really kind of hidden data from the National Park Service, which I managed to scrape up, and it was something called the Nationwide Rivers Inventory. It's now online, actually. But basically, I did some statistics here with help from my wife on these rivers, and found that there were only 42 natural, reasonably natural, free-flowing rivers in the lower 48 states that were 200 kilometers in length. That's not very long, and that's not very many. And furthermore, only a tiny fraction of the most natural rivers in the United States were federally protected, for example, as wild and scenic rivers. So I thought this was a bit of an eye-opener. I think a lot of us came to realize that, gee, maybe we should pay attention to conservation. And I was really pleased to see in subsequent years that presidents like Charlie Rubini and Len Farrington took this idea and started to get NABS more involved in conservation. Other people like Kathy Pringle and Nick Allman led the way on the new Conservation and Public Issues Committee, and that really pleased me to no end.